In this video, we're going to look at a couple properties dealing with your definite integrals. And the first one we want to look at here says that if you have a function f defined at x equals a, then if we look at the integral going from a to a for your function f of x dx, we're having the same lower limit and upper limit here, then I think it should be obvious then your integral is going to be 0. And in particular, if you think of this as calculating the area of some function, now again, I don't want to always think we're looking at the area, but if you were to think of this as calculating the area, then if you were going to integrate from a to a, then there's no space there for area, so it's certainly going to be equal to 0. So if you have the same limits, your integral will equal 0. And the second one here says if your function is integrable, so that means we're able to integrate the function f on the interval from a to b. And if we switch the limits here, and I mentioned this in the previous video, if you switch the limits from b to a for your function, then that's going to be equal to the opposite of the integral from a to b. So here normally you want to go from your lowest to your highest limit, your lower limit to the upper limit. But if you switch them, you're going to have the exact same numbers, just you're going from one's going to be positive, one's going to be negative. And this was kind of pointed out, the next theorem here, property talks about the additive interval property. And this states that if you're going to integrate on the three closed intervals here from a to b to c, if you were to split this up, then the integral from a to b is going to be equal to the integral from a to c plus the integral from c to b. For example, if I had a function here that we were to draw out, and if we're going to integrate from a all the way to b, so here we have the integral from a to b, and we have some point in between here at c. What this indicates, if we integrate from a to c and add that to the integral of c to b, I believe that's kind of intuitive and logical that integrating from a to c, then you're going to calculate this region, and if you integrate from c to b, you're going to calculate this region. So therefore, if you add it together, you're going to get the integral from a to b. Now, let me pose you with this situation. We have our same graph. We have A, we have B, and we have our C, but this time C is located over here. Is it still true in this case that the integral from A to B is equal to the integral from a to c plus the integral c to b? Now you may want to pause the video and see if you can figure this out. Does this make sense based on this property up here above? A to b, does that equal a to c plus c to b? Well, this is where you need to take in this property up here where we talked about switching your limits. That changes the sign of our integral. So if you notice down here, when we go from c to b, we're reversing the order here. So for example, if we're looking at the integral of c to b, if we integrate c to b, then that's going to be equal to the opposite or the negative of b to c. So really with this problem, what we're indicating is we're going to integrate from a to c, all right, and a to c is going to go all the way out here. But then if we integrate c to b, that's really the opposite of the integral b to c. So we're going to subtract away this portion, and then obviously we're going to be left with the integral from a to b. And again, all of this is due to the fact that we're switching the order and we're making our integral negative. So let's see if we can apply this to an example here. If we're given the following two integrals here, we're integrating from 0 to 3 f of x dx, and they tell us that is equal to 4, and the integral of f of x dx from 3 to 6 is equal to a negative 1. So for the first one here, they want us to find the integral of f of x from 0 to 6. Now we don't know what the function is, but we know that 0 to 3 is 4 and 3 to 6 is negative 1. So basically what that tells us, we could integrate then the integral of 0 to 3 f of x dx plus the integral of 3 to 6 f of x dx. And we know that we're going to end up with 4 plus a negative 1, so therefore your answer is 3. So this is reinforcing the idea that we can add these two intervals together from 0 to 3 and then from 3 to 6, and that's going to give us the integral of 0 to 6. And here we have the integral of 6 to 3, the integral of f of x from 6 to 3. Notice there we're switching the order, so we know that the integral of our function f of x dx from 3 to 6, we know that, and we know that it's going to be the negative here, so therefore we're going to end up with the negative of this integral, which is from 3 to 6, which is 1. So we have a negative, negative 1. So this negative is the negative because we switched the order, so therefore we end up with a positive 1 for an answer. And again, this is due to switching your limits. And I'm hoping the last one here, this third one, the integral of f of x from 3 to 3, I'm hoping this one is pretty obvious. We're integrating with the same limits, so certainly that's going to simply be 0. And one last example here to look at. We have the integral of 3 to 6, and we have a negative 5 times f of x dx. So the negative 5, I want to reinforce here that this negative 5, we can actually move the negative 5 out front so that we have negative 5, because that's just a constant multiplier, and we can leave the f of x dx here, and we're still going to integrate from 3 to 6, so we have the negative 5 out front, and we know the integral of our function from 3 to 6, that is given to us up here to be equal to a negative 1, so we end up with negative 5 multiplied by negative 1, so your answer is a positive 5. So this is just a quick review of some of the properties that we have with our integrals. And keep in mind, if your limits are the same, your integral is 0. If you switch the order of your limits, you're going to have the opposite sign. And of course, the additive interval property, we can integrate from a to b, and that'll be equal to the integral of a to c plus c to b.